Hey guys, good morning. Today we are going to learn about curl and how to create an HTTP client and HTTP server in Golang. We could start with curl. So curl, which stands for client URL, is a command line tool that developers use to transfer data to and from a server. So curl stands for client URL used to transfer data to and from a server. At the most fundamental, curl lets you talk to a server by specifying the location in form of a URL and the data you want to send. So with curl, we are going to specify a location or a URL of a server we want to talk to, as well as the data we would like to send to a server and the data we receive from a server. Curl supports different protocols, including HTTP and HTTPS, and runs on almost every platform. So, in short, curl is a command line utility which allows us to send requests to server. And since we are learning how to create a server in Golang today, we are going to test it. What are we going to test it using? The curl command. That being said, let's see some of the advantages and some of the whys you should be you learning curl. It is highly portable. It is compatible with almost every operating system and connected device. So highly portable, and no matter what operating system you use, you can download and install curl on your machine. It is used for testing endpoints to check if they are working. So if you write a server and wrote an endpoint in it, and you want to check if your endpoint is accessible and or if the authentication at your endpoint is working correctly, you could use curl to do that. It can be verbose, providing details of exactly what have been sent, received, and which is helpful for debugging. So we'll see a lot of this. We'll be printing a lot of details when we send requests to our servers. So this will be helpful. It has good error logging and it can be rate limited. We'll see all of them in action when we actually use curl. So again, when should you use curl? There are other alternatives. Let's see what other stuff we could use to send requests to servers. So one of them is browsers, of course. Second of them is Postman. It is also like curl. You can send requests to server, receive. Postman is more like a UI tool. So you could actually see what request you are sending in the UI and look at the response. You can also share a bunch of requests. So if your server has 10 requests, you could create all of them and share with your friends via Postman. But it's a UI. So let us suppose you are SSH using SSH to log into a remote server. Now that server has no UI. So at this point in time, you have to use curl to send requests or receive requests or to test if your server is working. So to answer the question when you should use curl, mostly when you have no other good UI options. So when you have to use a command line tool, curl is one of the best. Moving on to some of the flags. So these are important flags. Do you have to remember any of them? No. So you don't need to remember it. You can follow the documentation, do curl hyphen hyphen help according to your needs. I've just added some of the important ones for your reference to check later on. I'm going to highlight some of them because either we are going to use them in our upcoming session or I have asked it as an MCQ. So I have to tell you, I will be highlighting some of the important ones. Just pay attention. Let's see if any of them is in the slide. Okay. Capital O, download the file and save it under original name. And X, capital X. So this will be using a lot. Specify the HTTP method to be used while sending the request. So there are different HTTP methods. Post, get. We'll be seeing what they are in the coming slides. But yeah, let's see if there is something else. Yeah, hyphen D, specify the data to the server. As you can see in an example, small d and key value pairs. So you could send key value pairs, you could send JSON data using the hyphen D. Uh, Capital U or hyphen user, specify the authentication data by passing a pair of login password. Capital F, submit form data as post request. Limit rate, limit the downloading speed. Last one is actually important, which is capital L or location. Follow curl redirect using HTTP location header. So sometimes what happens when you send a request to server, it sends you back a redirect that you should go to this website instead, or this website has been relocated to this specific address. And if you want your curl to follow all the redirects, you specify the flag hyphen L. Small v, make curl verbose, print a lot of logging, HTTP headers and everything. Let's see if we have anything important here. Yeah, capital H is additional HTTP request header. If you want to send HTTP headers via curl, this is how you do it. Capital H, then key of the header, and then its value. So yeah, this was pretty much it. We'll be doing a lot of hands-on of curl when we get to it. I'll just show you one simple demo curl https hyphen dot google.com. So if you curl google.com, it give. Let me see if I could increase the text or something. Text font properties. We make it 12. Okay. Okay. Maybe this looks better. So it sent back the whole HTML page. We don't need to understand all of it. If you want to go through curl flags, curl hyphen help, there is a list of flags. I recommend going through some of them. But whenever you use curl, you'll mostly be writing it, typing it out on Google. This is what I want to do, how to do it on curl. And like whenever you get an answer on any website or Stack Overflow, you check out the flags and then read the documentation. For example, somebody tells you to use the capital T flag, then you check out the documentation, look what it does. So next time you don't need to Google it. So yeah, this is the best way to use curl. Yeah. So do you have any questions about the curl, its usage? Don't worry about the hands-on. We'll be doing a lot of hands-on about curl. But do you have any questions like you're not convinced why we should use this? You could type it out. So if you are good to go, you could just mention good to go in the chat. So we could proceed. Good to go. Good to go. Okay. Okay. Awesome. Thanks for responding. Let's move on with this. Yeah. Okay. Awesome. So you might have seen this image a lot of times. This is a typical client server model. Client initiates a request, server looks at that request, processes it, and generates a response. Now let me ask you a question. So do you think a machine could be a client as well as the server at the same time? Is this possible? Let me repeat it. Could a machine be a client and a server at the same time? Yes or no? You could answer in yes or no. Yes, yes, yes. Of course it can be. Yeah. Awesome. 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 Thanks for confirming this. Now, let's look at how do we create an HTTP server in Golang. So, we could call HTTP dot listen and serve. It takes two arguments. Give me 1 second. Yeah, sorry about that. It takes two arguments. First one is string. Second one is of type handler. Let's look at the first argument first. So one is the address we want to start the server on. It's in the form host colon port. So if I want to start a server on localhost, I will do 127.0.0.1 colon whatever port number, let's say 8080. The second argument is an interface. It's a handler. And what is a handler? It's an interface which has one method, serve HTTP. It takes two arguments, response writer and a request. So any type which implements serve HTTP, we can pass it as a second argument. So to repeat, to start a HTTP server, you can call a function HTTP listen and serve, which takes two arguments, a string and a handler. Listen and serve listens on the TCP network address ADDR, which is the first argument, and then calls serve with the handler to handle requests. So it will listen to a port, a TCP port, and then call a specific handler, which will then handle our request. Handler is typically nil, so we pass handler typically as nil, in which case the default serve mux is used. Now, before we see what is the default serve mux, let's just run this code. Let's try to create a server. Now I'm going to remove anything we don't need from here. We are just going to start this server. Let me save this. Main.go. So this is starting the server. Anything in the chat? Increase the font, please. Let me see how to do that. Preferences, setting, text editor, font. Let me do 18. Let's see if it works. Again, unfortunately, I don't know how to do this in terminal. So I've increased this font. I'll read out every command and typing. So I've just done a go run main.go to start a server. Now, what we could do is send request using curl http 127.0.0.1, and let's do port number 8080 hyphen hi. Well, before we see what replies, let's see what we are doing. We have a main function starting server. We have listen and serve. We have passed localhost and port number 8080 and passed the handler as nil. What I do is I try to curl it and let me pass the hyphen v, which stands for verbose, which will print more information. Now, if we check this, we have gotten HTTP response of 404 not found. Now, why have we got not found? Because we haven't defined any path to it. We haven't said if this is the URL, I want this handler to handle this. Now, who is responsible for all of this routing or keeping track of which path should be handled by which URL? It is done by default serve mux. So default serve mux is a special handler which in turn calls other handlers. You can think of it as a hash map of URL patterns and handlers. So it will contain, if the request is slash users, call the get user handler. Or if the URL is slash admin, call the get admin handler or process admin handler. So this is how you should think of it. If we look at the struct, there is a map called string and mux entry. Mux entry has a handler and pattern. So this is what the default serve mux do. It calls a handler for a specific pattern. Now let's say how we can define the pattern in our default serve mux. This is the function you need to call http dot handle func. Now this takes two arguments. One is the URL pattern, for example, slash users. Second one is the handler function. Now, if you look closely, handler function takes two arguments. One is the response writer and one is HTTP request, a pointer of type HTTP request. So you could create your own function and pass it as an argument. Handle function takes two arguments. One is pattern, second is handler. So it will call a handler on this pattern. Handle func registered the handler function for the given pattern in the default serve mux. So let's actually try to write this. If I write a function, let's name it welcome handler. The first one was response writer, http dot response writer, and the second one was request. So a pointer to request and a response writer. I'm going to name this W and name this R. So we have created a second argument. Now, if I want to write a response, I can do fmt.fprint, write welcome to server, and now let's go back to a slide and see what do I need to define this handler. http.handle function pattern, and we can pass this handler. So http dot handle func, I will pass slash welcome and pass our welcome handler. So now our handler should be registered. If I stop our server, start it again. Okay, I have stopped the server and started again. If you can't see the terminal, now let me clear the screen and try to call welcome. Now, if you can see, the last time it returned page not found. Now it returns HTTP OK as well as the string welcome to server which we sent. So now we are able to register handlers. We could register a part. Yeah,
I have.
please.
What does response writer mean?
Response writer is, as you can see, an interface. So anything which implements this interface could be used as a response writer. So yeah, by default, it's an interface. It is used to send a response back to the client. So
Okay.
any request there is, yeah, please go ahead. Were you asking something else?
No. Thank you for replying.
Okay, this is used to write response back to the client. It contains all the HTTP response, like the status code, headers, and everything. We'll see more about this in the upcoming slides. And this is the request object. So this contains all the attributes of request. We'll be seeing request object in detail in the coming slides. So now, since we have seen how to register a handler, let's see what are the rules and how the pattern matching works in the default serve mux. So let's go ahead. Okay, longer patterns take precedence over shorter ones. Let's say we have registered a pattern with images slash and it is registered to a handler h1. We have registered another pattern images slash describe. It is registered to another handler. Now if I call slash images slash describe slash test, the precedence will go to h2 because longer patterns take precedence over shorter ones. Uh, Only slash matches all the paths not matched by the other registered paths. Okay, so if I just put a slash, it will match everything if it's not matched by other paths. Can you describe handler once again? Yes, of course, of course. Yeah, let's look at it. So this is how you register a handler. This is in the handler function. This is how you register a handler. You could pass a pattern and a handler function. So the function signature of handler is already defined. So we can write a custom function as long as it matches this method signature. Okay. So what is the method signature? It contains a response writer and an HTTP request. Now you can think of response writer. I mean, the name is pretty obvious. It is used to write the response of HTTP request. And the second one is the request itself. So R here will contain all the request attributes, like who is sending this request, what HTTP methods they use, what are the headers of it. And using W, we can write this to our response, like what the response status should be. Should we send a good HTTP response or send a bad request response or send a internal server error? So this is the method signature, and we could pass this method to this function, which registers this welcome handler against this path. So is this better, or I like if you want to ask something, you could unmute and ask Ravi.
Yes, slash welcome. I didn't understand.
Yeah, could you repeat
Pattern.
it?
Hello.
Yeah. Can you repeat your question?
Hello.
Yes, you're audible. Can you repeat your question? Yes, Ravi, you are audible. Could you repeat your question? Uh, Guys, am I audible? Can you hear me?
Yes.
Okay. Ravi, could you please repeat your question, or anyone else who heard his question? Could you bring light to it? Okay, no worries, Ravi. Type it out. We'll come back to this. Okay. Anyone else has any question? Did you guys get it? Please
Yeah,
type
I
it out.
have one question regarding the welcome handler.
Mm-hmm.
Here we are printing it to for like demo purpose, but in real time, I think we'll have to return the response, right?
Yes. So fmt.fprintf writes to W. Okay.
Okay.
So it is writing in the response. We are passing the response writer to it, and it's writing welcome to the server to the response. So when we send a curl request, you can see that we have got this response welcome to the server.
Okay.
So this has come via HTTP.
But we are passing by value, right?
I don't get it. Could you?
To the welcome handler function, we are
Mhm.
passing the request writer. Yeah, response writer is passed by value.
Yeah. So this is an interface.
Oh, got it. Got it.
So it writes in the response. Yeah. But good question. Thanks for asking. Okay, so Ravi has responded. Okay, what is the welcome pattern? So when you send a request, you write a URL, right? Let's say www.google google.com/login, right? So this slash login is a part of google.com, right? This is handled separately. So this is what it is. It's a slash welcome. It's a URL pattern. It tells you if the request is on localhost/welcome, I want this handler to handle it. If the request was something else, let's say welcome/user, not suer, user, nobody's suing anyone, user handler. So I want a user handler to handle it because it's a request related to user. I want a user handler to handle it. So this is a URL pattern which is going to get matched. Is this clear? Okay, Asgar. Okay, thanks for confirming. Now, let's look at this second point. Slash matches all the path not matched by other registered patterns. Let's see a curl request. I say hello. Now, what did this return? Let's look at the HTTP status code. It said not found. So it did not find this pattern. What if I want to I want to create a pattern which matches anything on the server? So let me clear the screen and write literally anything here. I want this to return instead of 404, I wanted to return a generic error message or a generic function saying, hello, welcome to the server. I think you are at the wrong place. So we just pass the slash handler and let's write a new handler like generic welcome again http dot response writer comma r, and it is a pointer to http dot request dot request, and again we are going to use fmt dot fprint saying welcome to the server. The page you are looking for does not exist. Okay, and I'll pass this generic welcome function to the slash handler. So this is what we are doing. We have registered a pattern called slash welcome. So any request with slash welcome will be handled by a welcome handler, and anything, absolutely anything which does not match with slash welcome will be handled by this generic welcome. So let me just stop our server, run main.go if you can't see screen, and let us start. Let us pass like slash anything. Now this says welcome to the server. The page you are looking for does not exist. And it's where is the HTTP response? Yeah. So this is HTTP OK, sends the correct response. Now let us again do a welcome to the server, and it prints HTTP 200 OK. So the welcome is handled by welcome handler. Anything which does not match welcome is handled by our generic welcome handler. So does everyone get these 2 points? There is,
Hello.
yeah, please go ahead.
Like, can you run the server after only writing the slash at the end, not any message? So, can you go to the terminal where you were running?
Yeah. Do you want to go to terminal where we are running curl or the server?
Running curl.
Curl. Okay.
So, can you restart the server? Yeah, only this much.
Okay.
So, any website, if we run this like google.com slash, so it will only lead to the main Google page.
Right.
So in this, it says that it does not exist.
It does not say it does not exist, right? It says welcome to the server. The page you are looking for does not exist. So we printed this custom message, right?
Okay.
We could also just say welcome to the main page, or we could welcome to the main page. So this will behave like what normal google.com does, right?
Okay.
Let me stop this server, run it again. Now if I do this, let me clear the terminal. Now if I just do a slash, now it will do a welcome to the main page. So yeah, we could do something like this.
Okay.
What is the second argument in listen and serve? The second argument is an HTTP handler. Okay, handler. Let me go back to the slides. Handler is an interface which implements a method called serve HTTP. So any type which implement this method could be passed in as a handler. The handler, we typically passed it at nil, because if we pass it at nil, a default serve mux is used. What is default serve mux? It's a special handler which in turn calls other handlers according to the pattern and the handler we have registered. So what I wanted to ask you guys. Okay, that is clear. So are we good with these 2 points? There is a third point which is a little tricky. So if you are good with these two, we can move to that. If we are good to go, you could type it out in the chat box. Awesome. Thanks for confirming. Let's move on to the third point. If a subtree has been registered and a request is received naming the subtree without its trailing slash, serve mux redirects that request to the subtree root adding the trailing slash. Now, what does this mean? Let's try to visualize this. Okay, images. Let's say we have registered a URI called images slash. Now, notice the slash at the end. Okay, we have registered images slash, which is registered with a handler h1. Now, a client called gets images without a slash. So this is what our serve mux will do. It will send a redirect saying you have to go to images slash and not images. So this is what the third point means. We could test it out immediately. So keeping the example similar, let's say we have a images function. Yes, Shobit. It will match slash x and slash y and no other roots. Yes, that is correct. It will match them. We could also I could demo this after some time. So I've registered a handle function images slash which calls our welcome handler. So let me just stop it, run the server again, clear the screen. Let's call images. What if I want to show 404 for wrong pattern and also slash for the main page? Can we do this? Technically no, because when we say slash, we are telling it to match any pattern which does not match, right? So technically no, you cannot do that. Maybe there are some tricks to achieve this. Let's talk more about this later. So let me move on with the example. But sure, good point. Let's bring it up a little later. So I have sent this request to images. Now notice there is no trailing slash here, and in our code there is a trailing slash. Okay. Now what happens if I send this request? Well, I got a HTTP response 301 saying this has moved permanently and you should redirect it to slash images. Now it is telling me to go to slash images. And this is what we established in our PPT, right? If I register a handler with a trailing slash and then send a request without a trailing slash, the serve mux will tell me to redirect with a trailing slash. So now since we got a redirect, and let's see if there is something we could do to follow this redirect. Now, if the server tells me we have moved permanently, you need to go to slash images. Now, how do I tell curl to follow this redirect? Well, we have a flag, capital L, which does that. Maybe we have in our command list. Let me check if we have. Okay, capital L, follow curl redirect using HTTP location header. Do we have a HTTP location header? Yes, we do. So following this, it will follow the redirect. So first, let me clear the screen to avoid any confusion. Second, I will pass capital L so it actually follows it. Now, let's see. We got a welcome to server, but let's see what happened first. In the first request, it told us that the request has moved permanently and you should go to images with a trailing slash. We accepted this and we sent a request to get images, and get images was registered with the handler. So it returned HTTP 200 OK and returned the message welcome to server. Now, so did you understand what happened here? Why it sent a redirect? Because we had a trailing slash when we registered the handler, but when we sent the request, we didn't add a trailing slash. So servmux redirected this request. Is this clear? Does everyone understand this?
Hello.
Yeah,
Yeah.
please go ahead.
If we have two methods, which are listening to the first pattern is slash images, and the other to slash images slash ABC or anything after that.
Hmm.
If we write only slash images slash, so will this redirect to the first one we have written or the next one we are trying to redirect?
So depends. We are sending a request just to slash images, right? Nothing else.
No, we are sending it to slash images. Yes.
Okay, then it should send it to this welcome handler. Let's just verify it very quickly. So you said slash images, let's say ABC, right? Let's do this. Let's create another dummy handler, and welcome to server from dummy handler. Well, create a request. Let me stop and restart the server. This is what you had in mind, right?
Yes. Yes.
Awesome. Let's just now clear this and call images. So it called welcome to the server.
But it should have asked for a redirect to slash images ABC one also, right?
No, because it matches with the slash images, right? It exactly matches with the slash images.
Uh, okay, partial matching is not there.
Yeah. And an interesting point is, let's say if I do slash images slash abc and slash efg, okay,
Okay.
this is okay. This shouldn't have redirected to the server. Oh, that's the issue. We didn't save it. We didn't save our server before restarting. Great. Let me just restart it and try it again. Okay. There are a few questions. Give me a minute. Let me first clarify this one. Slash images slash bbc calls in the dummy handler. Welcome to the server from dummy handler. Makes sense. Ish. ABC. Okay. PC/G. Okay, this. Okay. We are good to demo. So if you call slash images only, it will match welcome to server because it perfectly matches with this pattern here, right? But let's say if you do slash abc slash efg, okay, now this will return welcome to the server from dummy handler. Why did it go to the second handler? Now this matched with images. If you could see our request here, this matches with images as well as images abc, right? But precedence will be given to longer patterns instead of shorter ones. So if it matches with both of them, precedence will be given to longer patterns. And if it doesn't, then this one. So I hope this makes it clear.
Okay. Thank you.
Hello. Can we exchange this line number 10 and 11 and then call for images only, images slash?
Absolutely, let's do that. Okay, let me make sure I save it this time. Yeah, just run the server again and let me clear this. Just call the images slash and it will call welcome to the server. So it's not up to the sequence of our declaration. It's up to the rules which we have in the server marks. Like we have seen. Okay, thank you, but good observation. Thanks for asking this.
So yeah, if like we pass only images without slash, so what will happen?
Only images. Yes, that's what we are talking right now. So if you send only images, let me clear it. Only images. So what it does is it gives you a redirect. It tells you that the site you have called get images has moved permanently to images with a slash. So you should go to images with a slash. So that's what we tell you. What if we define images only without a slash? Well, we are going to come to that, but great point.
But the preference should be given to slash abc.
In which case you're talking about?
If we only pass images.
Yeah. So right now, but it does not match with ABC, right? It just matches with this part. If it matches with ABC, if my request matches with ABC, then here it has something like EFG, then the preference will be given to welcome to the server from dummy handler. So we can conclude that the preference is given to ABC because it matches this pattern, right?
Yeah.
Let me write down this request images slash abc slash efg. Sorry. So this URL matches with abc as well as the images, right? Matches with both of them. In this case, the preference will be given to the longer pattern. But if I remove this, it doesn't match with ABC, right? Only one. So only this handler will be called.
Okay, got it. Thanks.
Like if we do images slash ABC without the trailing slash, so will it match to images or will it tell that it has been permanently moved?
Well, I haven't tried this out. Let me try it. Yep. Move permanently. So the rules are same. It is saying that where is the get request? Yeah. get ABC has been moved permanently to ABC with a slash. So go to ABC with a slash.
Can you just write AB?
AB, okay. It will be matched with welcome to the server. Again, the first one. So if you match AB, it doesn't match with this, right? So it will go to the root handler. So it will just skip this and match it with images.
Okay, yeah. So is it like if you miss the slash, only then the redirect will happen, and otherwise?
Yes,
Okay.
that's correct. That's correct. Now there is a solution for redirect also. Let us come to that. We'll see the solution to redirect and we'll take a 15 minutes break. So now I don't want this redirect to happen. How do I solve it? Well, register a handler without slash. So we could register a handler without slash. If the user calls get images, it will now give a status HTTP OK or whatever you want the handler to do. At least the correct handler will handle the request. Let me make it images. And yeah, so this will call our dummy handler. This will call a welcome handler. Let me save it. Stop the server. I'm just restarting the server. Let me clear this. Now, if I send a request only to images, this should give me a 200 OK, and it does. So if you register a handler without slash separately, it will not ask you to redirect and redirect to the correct handler. So are we good so far? Yes. Okay. Okay. Awesome. So it's almost 10. What is we register only images and send images in the world. So it should match with slash images. He's asking what if we only register images and call. So we could try it out. I've commented the code. It only calls dummy handler. Let's go run main.go. So it said page not found. Interesting. Yeah. So it's not matching with slash and it says page not found. Yeah. So there we go. Okay. So if there are no more questions, let's take a 15 minutes break and we could meet after 15 minutes. And let's learn more about status codes and stuff. Okay, I'll see you at 10:15 then. Status. Okay, so let us start with HTTP status. I mean, you might have seen we are keeping track of what HTTP status our handlers are returning, or at least our server is returning. Here's how you write your own HTTP status. W being the type of response object, you call a method write header and pass an integer, which is the HTTP status code. So first, let's see what kind of different HTTP codes are there. So there are I mean, you might already be familiar with this. Let's just repeat it for everyone's sake. So there are some HTTP codes starting with 1. So 1XX. These are generally used to denote that the request was received and we are continue the process. For example, 102, which means processing. We have received your request. We are processing it. Second is the most commonly used, like 2XS. That means this is the request was successful. We received, understood, and accepted your request. The third one is 3XX, redirection. Further action needs to be taken in order to complete this request, like 301, move permanently. We saw how not adding a slash caused us to redirect, and to denote this redirect, we use 3XX HTTP status codes. The next one is 4XX client errors. So we send this back whenever there is something wrong at the client's end. Let's say your API really needs a email parameter, like you need the client to pass the email to process the request, and the user hasn't passed that email. So you send a 4XX error, like for example, 400 bad requests. You haven't sent email, please send back the email. We really need this. Any problem which is at the client's end, to denote this, we use 4XX error codes. Now, there are 5XX error codes which denotes that something has gone wrong with our server. For example, a request has come, user has entered their email and password. I need to validate this email and password from my database, but my database service is down. Now I can't really blame it on the users. So I denote that there is something wrong at my server end and I try to fix it. Okay, there is some background noise at my end. Let me see what I could do to fix it. It seems to be gone now. So let us continue. Oh, before we continue, actually, we should practically do some of this. Now, w dot write header, sorry, not this one, w dot write header, and it takes an integer. Now, Golang has made all the integer constants, so all the status code as constants. So in the HTTP package, you could say status continue or status okay. So we are going to send bad requests. So our welcome handler is going to send bad requests no matter what. So let us try this. Do we actually have, well, let's put this in dummy handler since that handler is working right now. Let me save this, run our server again. Well, before I do this, let me clear the screen. Call main again. As you can see, now this returned bad request. Why? Because we hard coded this. So any request we receive, we say it's a bad request. Of course, you shouldn't do this. This was just for testing. So this is how you return custom status codes. Now, we are talking about request struct. Let's see, in the dummy handler, we have two arguments. One is the response writer, one is the request. Let's see what this request objects looks like. So I have noted all the important fields of this request here. So this is not all the fields of request. It contains a lot more fields. I've noted down or listed down some of the important ones. So first one is the method. Now this contains the HTTP method. What we could easily do is print it out. So in our dummy handler, let's see fmt.println, we are printing out to the console the the request was of r dot method. Okay, so we have just taken the request object and printed its method saying the request of was of this method. Okay, let's see if the server run it. If you run the server, let me clear the screen, send the request. Let's see what it prints. So okay, I don't know how to increase the font of this. Let me highlight this. The request was of get. So whenever in curl you don't specify the HTTP method, it sends the request with get. Can you specify your own method? Yes, with capital X, and let's say this time we are sending a post request. Let's check the logs. It shows the request of was of post method. There is another method called delete, and if you send this request, the request goes of delete method. So this is how you send different methods. Any doubts with this? With HTTP methods, this is pretty straightforward. Whatever you send, it is going to get populated in the request object. So this is pretty straightforward. If you have any doubts or want me to do something in the code, you could write it out in the chat. Is there such a thing? Okay, so let me mention one thing. We were not sending the HTTP code till now, right? But it was showing 200 OK every time. So by default, if you don't write anything, it will default to 200 OK. So if we don't mention this line, it will always return 200 OK. So that is the default value. Okay, so
Hello.
yeah,
Can
please.
we run our custom like HTTP code?
Could you repeat it?
Can we define our custom HTTP return code?
No, these are standard defined. So
So we
do you
can't
think,
define like something happens in our server and we want to return it as an HTTP request. So like can we define 575 or any number? So can we do?
no, it has to be it is a standard. So something wrong went on your server. We already have a code to denote that. That is internal server error. So
Okay.
everything that could go wrong is already defined as a part of standard. This is done because everyone writes their server, right? So there are so many servers. If everyone starts defining their own error codes, it will be very difficult to manage it, right? So there is a set of standard defined, everyone follows it. So this is the reasoning behind following a standard. Okay. So is there anything you guys want me to try out, or any questions? Okay, since there is no response by the law of HTTP, I'm going to assume everything is 200 OK, and we are going to move on. Okay, this slide contains different HTTP methods. There are four most important of them: post, get, put, and delete. Post is used when you want to create a resource on the server. Get is used to retrieve a resource. Put updates an existing resource. If the resource is already there, you want to change it, you should use the put method. And delete method to delete a resource. These are not the only methods, HTTP methods, that there is patch, there is options, there are a lot of them, but more often than not, you will be using only 4 of these. Well, let's talk about HTTP headers. An HTTP header is a field of an HTTP request or response that passes additional context and metadata about request or response. So if you want to pass any additional details, we use HTTP headers. One of an example is the authorization header. The HTTP authorization request header can be used to provide credentials that authenticate a user agent with a server following access to a protected resource. Well, let's see this in action. We are going to send an authorization server, not an authorization server, an authorization as a header, and use it as a credential. Okay. So first of all, let's go into a Go code. We have request.header. Okay. How do I get any header? Well, call a get method. The get method would take any key, which is name of the header. In our case, authorization. Now, what does the get return? It returns a string. Okay. So I'm going to name it API key. Now, if API key equals to 123, if it's 123, we are good to go. HTTP w.write header, HTTP dot status. Yeah, there a question. Yep. Thanks for pointing it out. Yes. It is equals to equals. So HTTP status okay. We are going to print it, and let's just do the API key was correct, or in other case, let's just do API key was correct and return. And if it was not correct, we could return an error. So HTTP bad request, API key was not correct. Let me stop the server, start it again. Clear. Let us send a request. Well, what it returned is a bad request saying API was not correct. Now let me add a header to a capital H and strings authorization. I hope I'm getting the spellings correct. Well, now if I send this with the correct header, authorization, this time it shows the API key was correct because in our code, it gets the authorization key, checks it against 123, and returns a status okay if this was correct. Now, yeah, so I think this is okay. Yeah, please go ahead.
You sent the last request authorization space colon space and 123. So was that space sensitive, or we can write it without space also?
So the documentation says it has to be that way. I have mentioned this here. Where is the H? That was supposed to be here. Yeah. So the documentation says it has to be space. Let's but try it without doing the space. Yeah. So turns out not case sensitive. Let me do 1, 2, 3, 4. Okay. 1, 2, 3, 4 throws API key was not correct. So the space is not required, but I would recommend it because of the readability factor.
Okay, thank you.
Yeah. So if you want to, like, this is only one header, right? An HTTP can contain multiple headers. So to support multiple headers, you can provide as many -fs and key value pair as you want. Okay, where were we? We were seeing the request object. Okay. So we have seen HTTP headers. Now, give me a second. Yeah, sorry about that. There are two fields I want to talk about. Form. Let me show you from the struct first. So form and post form, we are going to see how to access a form and the value posted by it. So let's start with form, which is of type URL.values. Form contains parsed form data, including both the URL fields query parameters and the patch, post, or put form data. So any form data which you send, these field will contain it. This field is only available after parse form is called. Parse form is a method. After calling the parse form method, the values in the form will be available. There is another field called post form. Post form contains the parse form data from patch, post, or put body parameters. Again, the field is only available after calling parse form. So what is parse form? It's in the next slide. The important part here is what is the difference between form and post form. So form contains the values in the URL fields query parameters, and post form contains the data only if the HTTP methods is patch, post, or put, and it is in the request body, not in the query parameters. So form contains all of the things which post form contains, as well as the fields in query parameters. So how do you practically read this? Well, before we see a practical example, what is this parse form method? Let's read a little about it. So parse form populate r.form and post.form. For all requests, parse form parses the raw query from the URL and updates the form. For example, you could see there is a question mark username equals to Ali. So parse form will also evaluate this and put it in the r.form. For post, put, and patch HTTP methods, it also reads the request body. So for these three methods, it will also read from the request body, parses it as a form, and puts it into both post form and form. The request body parameters take precedence over URL query string in r.form. So as you know, r.form contains data in request body as well as the URL, right? What if there is a same key in the request body as well as the URL? Which one would take precedence? So request body parameter will take precedence. So we could practically try this out. Let's in our demi handler, let's remove the API code. What we could do is just return status okay, status which is okay, and let's just hello from server. Okay, what we need to do is just fmt.println r dot form. Okay, we're printing r dot form. Let's just run this and see what happens. Connection refused. Okay, I have restarted the server. Now server is on. Let me clear it. Okay, so it says hello from server. The request is received. In the output terminal, it outputs an empty map. Why did it output an empty map? Because we didn't send it anything, right? So let me make it get and actually send it username equals to test. If I do this, let me check the output. Well, still it prints an empty map. Why does it print an empty map? Because as we said, this field is only available after parse form is called. So let's try it out. Let's try calling it r dot parse form. I've called this method. Now let me print this. Maybe add some additional details after parse form. Let me just call the server again. Well, now if you see in the output, before we call the parse form, the map was empty. After we call the parse form, a map contained username and its value test. So, and in the URL, let me just clear it and see if we had passed this in query parameter. So this is what it is, the form data. This is how you access it. Now, let us talk more about post form. Well, then need to change this one. Let me print r dot post form. What else? Okay, I've printed r dot post form. Now, let us see the output. Okay, we need to avoid the confusion. I will clear the terminal, bring it. Okay, we have restarted our server. Let's try calling this again. Well, it prints empty on both of them. Why? Because as we know, post form contains parse form data from patch, post, and put body parameters. So for this to work, we need to send data in body parameters. Well, how do we do that? Let's try it. First, we need to send the request as post. It's okay if we skip this. We don't need headers. Then we do a -d and username equals to test. Well, let's try this out if it changes anything. Yes, so when we did a post and send the data and request body like this, it actually populated the post form as we promised. So it's very simple. The form will contain the data from query parameter as well as the request body, and post form will contain data only from the request body. So is the form values clear? Do you want me to repeat it? or have any questions, please ask. If you have no doubts, you could print, you could write no doubts. So I know at least you are listening. Oh, SCTP. Okay, nice. Okay. Okay. Then I guess we're good to go. Okay. The last thing before I show you the HTTP clients, I'm going to show you a type decoder. Like, how do you handle JSON requests? Now, before I do that, I'm sitting in a room which is very close to traffic, and it's almost 10:45, so the traffic has started flowing. Give me 5 minutes to shift the room so that there is not a lot of background noise. Give me 2 minutes. Okay, I'm back. Let's try to learn how to handle JSON values. Okay, so to handle JSON values, you need a decoder. You need to parse an input stream and decode it into a struct. Okay, for this, we use a type which is decoder. What is a decoder? A decoder reads and decodes JSON values from an input stream. An input stream like a response writer. Okay, now let's move on to the next point. Now, how do you get a decoder? There is a function called new decoder. New decoder returns a new decoder that reads from R. So to decode a JSON, we'll have to have a JSON input, right? So where does it read the input from? Well, it has a parameter called IO reader. So you could pass an IO reader and it reads the JSON and decodes it. To decode it, we call the dot decode method on the decoder. Decoder reads the next JSON encoded value from its inputs and stores it in the value pointed to it by V. So we have to send V as a pointer, as a reference. So it stores the value at the correct place. The best way to understand this is to practically try it out. Let me remove the form stuff. Well, let's create a type user, which is a struct. Now it is, let me think of some name. Now it just has name string called name. Okay. User has name. That's the only thing we are going to check. Now, as soon as we receive a request, we need a new decoder, right? So the package is JSON dot new decoder. We have gotten the new decoder, passed it W. Now, sorry, new decoder dot decode. Let me create a variable of type. I'm creating a variable user. So user name, so test. Let me just see what the error is. Decode it and then print it out if error is not equals to null empty dot. Okay, we are going to print in the error. We need to declare the errors. Yeah. Let me check what the error is. Cannot use as value in argument. Oh, of course. Sorry. Yeah. So what I did was accidentally pass the response writer to it. Well, we are going to receive a request body, right? So the data is going to be in the request. I'm accepting the data from the user. So of course it has to be a request. And we have to read it from request body, which is of the type IO read closer. Okay. So that was the compilation error. Now let me fmt just println and let me print the user. Now what we could do is, yeah, this looks fine to me. New decoder, decode it to you. We don't need to define this. Let's keep it as empty. Let's create a blank user. After creating a blank user, I'll print it out. And after reading from the request, we have printed it out again. So let's just try this. I'll restart our server. Okay, I haven't saved this. So the server has started. Let me send a request to it. We're not going to change anything as of now. Let me send a request and show you what happens. So it is saying invalid character U at the beginning of the value. So it's trying to read the request body. When it tries to read the request body, it's saying invalid character U because we are trying to decode it to JSON, right? This is not a valid JSON. So it's telling us to please send a valid JSON, hence the error. So let me show you. So name and pass it as test. Invalid and looking at the beginning. Okay, what were we expected to pass? Okay, let me do a little cheating. Yeah, this was how it was supposed to be. Okay, yeah, it's working now. Let me clear it and explain it to you from scratch. So what happened was we sent the JSON body as a request. So let's try it out. It received the request. First, it printed the user, which we have created. Second, it read from the request body, decoded it into U, and then we printed the U and it contained test. Now let's print something else. Test -2. Now, if we send this, it will print test -2. The reason it was not working in the start was because instead, let me try it again. So instead of these single quotes, I was using double quotes. So it got confused where to stop reading because it didn't know where the quotation marks end. Because if I do something like this, now does the quotation mark end here or somebody else, somewhere else? So very confusing. So therefore, the outer quotation should be in single quotes. So that was the bug which was troubling me. So is the decoding part clear? I'll explain this once again before asking. So we use a decoder to decode JSON into our structs. We read it from request body. So we first created a new decoder and we then on that decoder called a method which takes any interface. So decode reads next JSON encoded value from its input and stores it at the value pointed to by V. So emphasis on value pointed to by V. So we are sending it as a pointer. And then after that, when we printed it, it encoded correctly and printed it in the right format. So any questions regarding this? You could, if you have any questions, you can unmute it and ask. Okay, no. So are we good to go? Does everyone get this? You could ask me to repeat if you want. Okay. So again, I'm assuming it's 200. Okay. Okay. Thanks for responding. Good to go. Okay. Awesome. You guys know what this JSON tag means, right? Are you familiar with the JSON tag, or just should I quickly explain it?
Yeah, can you please quickly explain?
Okay, so someone said familiar. Okay, let me quickly explain. So these are tags. You could provide some tags with struct. One of them is JSON. So while reading the request body, how does Golang know that we need to populate our name string with the name key in JSON? So this is our way of telling in the request body, whenever you receive a key called name, that key is mapped with our name string. Okay. You could name it ABC. Okay. Let me just name it ABC. Stop the server, clear it, and restart the server. Now, clear this command and run it. So now I haven't, the key is name, the value is test2. Okay. Now, if you see this, it didn't print anything because it doesn't know what we send it. It is expecting a key called ABC, which he is going to populate in the name. So let's try ABC, passing the key as ABC. If you pass the key as ABC, now this should work because it knows the key for the name string is ABC. And this is the syntax for it. Why I'm seeing this character in request? Can you elaborate, Yash? So where?
Actually, I'm seeing that character which I sent in the request in the curl you were sending every time after the JSON. So once it was not showing. So I was confused that whether it is there or only I am seeing it.
Okay, so are you trying it out on your PC?
No, yeah,
Okay, so you are seeing a symbol.
yeah, after the JSON.
Acha. Okay, we could try debugging this at the end of the session. So if we get time, you can share your screen and let's try to figure it out.
Sure, sure.
Okay. Now, like now we have seen how to receive a JSON response. let's see how to write a JSON response to. So for this, we use an encoder. Encoder does the opposite of decoding. So it will write JSON values to an output stream from a struct. For this, as we call new decoder, we'll call new encoder, write it to W, and then encode it. So let's try this out. So JSON dot new encoder. I'll pass the response writer. Since we are now writing it to the response, I'll pass the response writer and encode the U. So if there is an error, I want to record it. If the error is not null, I want to print the error. Okay, this looks pretty simple. If we restart our server, let me clear the screen for a better view. We get this in the response. Let me see if -I would print a better response. Okay, so as you can see, it is printing the correct response. Let me clear. Yeah, is there a question? Okay, so basically encoder does the opposite of decoding. So when you want to send JSON back in the request, you could do that. An important point, you need to write a header indicating that response is of type JSON. So w dot header dot set. So content type and application slash JSON. So this is basically our way of telling the response contains application JSON. So anyone has any doubts in encode decode?
What's the default type of content type? Yeah, I mean, here we are explicitly mentioning application slash JSON. What's the default type? Is it text?
It should be text. Let us confirm this. It could be blank too, and depending on the client, either client can assume a default value, or it could, or the server could send it. Let's just verify. Do we have a content type? Okay, yeah, it is text slash plain. So this is the default value if we don't send it.
Got it.
Okay, so is everyone clear with the encoding decoding? We have one last important type remaining, which is how to create an HTTP client. So let's begin with this. Client is an HTTP client. So HTTP.client is a struct. Its zero value default client is usable client that uses default client. That means you could just declare a HTTP client struct and use it to send and receive request. You don't need to configure anything by default. If you don't configure anything, it will use the default transport. Client transport typically has internal state cache TP connections. So client should be reused instead of created as needed. So if you want to send two consecutive requests, one a post, either a get, or any two consecutive requests. You don't need to create two client objects for that. You can create one client object and reuse it. That's what this line means. Clients are safe for concurrent use by multiple coroutines. Now, how do you actually send a request using client? I know how I can create a client object. It's very simple. I don't need to configure anything. But how do I send a request? Using a do method. So do sends an HTTP request and returns an HTTP response. It also returns an error. So let's see when does this return an error. An error is returned if caused by client policy or failure to speak HTTP, such as network connectivity problems, or non-2xx status code does not cause any error. So the error will only be returned by if it caused by client policy. So if I'm not able to send a request to the server, it will give me an error. But if I'm able to send the request to a server and server returns a bad request, so this will not cause an error because I was able to correctly send HTTP request. If the return error is null, response will contain a non-null body which the user is expected to close. So if the error does not occur, this response will have a response body, right? Because the server has returned us a response. Now we need to close this response body. We have a method for doing that. We'll see when we actually look at the code of this. Now, let's see what we know at this point. We know I can create a client struct and send a request using do method, right? Only missing piece is the request object. You need to pass request object to the do method. How do you do that? Well, using new request function. New request function takes a method like get, post, put, a URL which we are trying to send the request to, and a body, which is the request body. An example of this is, see, we have created an http.client. Now, since we have the client, we know we can call it client.do and send a request. What do we need to do that? A request. How do we create a request? Using http.newRequest. The first parameter is post. The second parameter is HTTP URL. So the URL. And the second is request body. You can also pass it as nil if you don't want to send a request body. After doing client.do, we are going to check the error. If there is error, we need to handle it. If the error is nil, we need to close the response body as per the documentations. So in defer func, we have done response.body.close. This is how you close a response body. Let me see if I already have an example. Okay, why are we here? Okay, let me remove this unnecessary stuff. Well, let's look at our main code, what it does. We have a user, which has two fields, user password. We have created a buffer for request body. Now, if you see new request takes a body of IO reader. So we have to create a buffer. That's what we have done. We have created a buffer and we have encoded our struct user and passed it into a buffer. Now we make a client. As you know, if we don't pass any configuration, it will use the default transport. So we are using the default transport. We have created an empty client object on which we can call the do method. To call the do method, we need a type HTTP request. How do you create a request? Like this. So the first parameter is post, the second one is the URL, and third one is request body. And after we check the error, we are closing the request body. We are reading the response and printing it out. I'll share the code snippet for you for the reference. So does everyone understand this code? Are there some doubts? Can you go through it briefly again? Why a close at the end? It is the document says you have to close the request body or it will be reused for the next consecutive request. So that is as per the documentation. Can you go through? Yeah, yes. Of course, we'll go through it briefly again. What's a buffer? Okay, so we need to pass the new HTTP request a type of body IO reader. Okay, IO reader is an interface. So if you go through it, IO reader, IO reader is an interface, okay, which implements a read method. So anything which implements a read method, you can pass through it because we want to read the data. Buffer is a type which implements the read method. Therefore we are passing it. Therefore we have created a buffer. It is not mandatory that you create a buffer and pass to it. Anything which implements that read method could be passed. So buffer is one of the thing which implements the read method. I'll share more documentations to look at it closely. Yeah, so to repeat it again briefly, let's go to our presentation. Yeah. So to send, now what we are trying to achieve is, now we have written a server. Now we are trying to write a client in Golang. Okay. To write a client in Golang, you could use this HTTP client struct. And you don't need to configure it. If you don't configure it, it will use the default transport. So we have a struct. On that struct, we have a method called do, which actually sends the HTTP request. So we have a struct, we know what method to call. The only missing piece is the request. So how to create a request? There is a function called new request, which takes some parameters method, a URL string, and a request body of IO reader and returns a new request. So we could use this function to create a request. And this is how the final code looks like. We have created a client. We've created a client. Now we know on this client, I can use a do to send the request. Now to send a request, I need a type request. How do you create it? Using this method. I've sent post. This is the URL and this is the request body. It could be nil. You could also pass nil here if you don't want to send the request body. So this is how you do it. Now, when you do the request, if the error is nil, if the do does not return an error, that means the server has responded successfully, in which case the documentation says you need to close the response body. So this is what we have done. We have followed the documentation and closed the response body. Now, before we wrap up, is this the easiest way to do a client request? Okay, yeah, you're welcome. If is this the easiest way to send a client request? No, no. So let us browse through some official documentation. This is the HTTP net package. Let me see if we can go through types. Okay, a type client. You could read more about this, of course. Well, when you read about client.do, there is something you need to understand. Generally, get, post, or post form will be used instead of do. So, Golang has simplified it for us. You could call a method get, which just takes a URL.string. So, you could do something like if you want to send a get request, client.get, it just takes the URL. So just you need to pass the URL and it receives two arguments. One is response and other is error. So you read the response, comma, error, and then you could do the same thing. So this makes our code much simpler, right? No need to write this request. No need to do client.do or anything. The get will take care of it. Similarly, if you want to do a post request, there is a type which takes the URL, content type, and a body. So I'll share the links, you can go through it. There is also a post form. So if you don't have a JSON request body and you just want to post the form data through a client, this is how you do it. So this makes the interface much simpler. Let me actually see if I could show you something more. Yeah. So let's see what this does internally. So internally, it is on client object. So it is creating a new request as we did. Oh, okay, I'm audible, right? Yeah. Okay. So it is creating a new request and calling client.do by itself. So it is internally doing what we did in our first example. That's why I decided to show you the first example, which is a little confusing, but this is how you actually send a request in Golang. While closing, I will share this link with you. As you can see, the net HTTP package is very huge. It contains so many methods. We cannot go through all of them within 2 hours. It will at least take weeks, if not months, to go through this. So I recommend going through this occasionally. And like, yeah, if you start working on projects, you will visit the documentation as per your needs. So yes, this should be considered as a source of truth whenever you are working with HTTP. So do you have any doubts before we conclude? Please ask them. Okay. I'm assuming you have no doubts. Let's just wait another minute. If something comes up, you can also unmute and ask right away if you want. Can you briefly sum up from the start? Of course we can. Yes. Let's do it right away. What about unit testing here? Yeah, you can mock HTTP calls. If you are interested, when I'm going to share the slides, I will also provide you some links on what are the best practices and how it's done, etc. So we could cover unit testing there. Okay, let's quickly do a summary of what all we learned today. Okay, let's skip the curl. Okay, so there are two components. One is client, one is server. Client initiates the request and server responds to it. This is how you create an HTTP server in Golang. It takes two parameters. One is address, second one is handler. You could also write your custom handler, implement serve HTTP, and pass it on. If you don't pass it, you pass it as nil. Default one is used. Now, the default servmux is a special handler, which in turn calls another handler based on the pattern. Well, how do you provide this pattern? Using the function http.handlefunc, which takes a pattern and a handler function. So it takes a URL pattern and a handler function, as you can see. There are some rules to pattern matching, like /all is match by all other patterns which are not registered. Now, there is another rule. For example, if you have registered images with a trailing slash to h1, and if you just call get images on it, it will return a redirect. And to solve this problem, you should register images without a slash, so it will redirect it to the correct handler. One thing I forgot to tell you, if you registered images /h1 twice, it will throw a panic. So returning HTTP status, this is how you return HTTP status. W.write header, it takes an int. Here are some of the status codes. You can go through them. Now, whenever you receive a request, you receive a request objects. Here are some of the fields present in request objects which you might be working with. We are going through some of them. There are different HTTP methods. So r dot method contains the HTTP methods in them. A client could provide additional details about HTTP through HTTP headers, and same with the server. While responding, server can add some custom headers. We saw one of the headers and how to write values in them. There is also form. So whenever you fill in a form, you need to access those values. There are two fields to do that. One of them is form, second of them post form. The difference is form contains the data from URL encoded values, and post form reads only from request body when patch, post, or put is used. Before accessing this, we have to call pass form. Pass form populates these values according to the rule we discussed. You could handle JSON using the type decoder while receiving the request, and type encoder while returning the request. So if you want to read the request, read JSON from request and store it into your struct, you will use the type decoder. If you want to do the opposite, convert your struct into a JSON value and send it back to the client, you will use the encoder. To now we have seen the server, let's see the client. This is the HTTP client. It's a struct. Its default value when you have just initialized the struct without providing any values, it uses default transport to call any method. We have to call any endpoint. We have a method called do. Do will call an endpoint provided that we have passed a request to it. How do you create a request? Using the following function, new request, which takes a method, URL, and a body. So this is the end code of it. I'll share this code snippet of the client with you, so you could test it out yourself. So any more questions? Okay, then that was it for today. Thank you so much for joining and listening in.